Today's lesson is about graphs of logarithmic functions. We already completed slide 11 in the Desmos previously, but we're going to start by reviewing this. This blue graph is an exponential function. We had found the inverse of the values in the table and graphed those, and identified this as a log function. In slide 12 of the Desmos, we have a much nicer version of the notes of what we just talked about of these graphs, that an exponential and log functions are inverses of one another. Here we're going to look at transformations of logarithmic functions, and we are going to identify their key characteristics. So the f of x function is this blue function on the bottom, and we can see that the asymptote is the y-axis, so it is at x equals 0. The domain is restricted by the asymptote, so that is going to be from 0 to positive infinity, or where x is greater than 0. The range for all logarithmic functions is all real numbers. If we traced this graph from left to right, we are increasing. So the increasing interval is going to be the domain. X is greater than 0, and it is not decreasing. So as we look at g of x, which is this top red function, we can see that we are subtracting a 2. This has caused the graph to shift down 2. Let's examine the key characteristics. So the asymptote is still at the y-axis, so still at x equals 0. The domain is still restricted by that asymptote, so it's also going to be where x is greater than 0. The range for all logarithmic functions is all real numbers. If we trace it from left to right, we are going up, so it is increasing on the entire domain, and it is not decreasing. Here we have the parent function is already completed, this f of x blue function below. So we are going to take a look at the g of x function. So one thing I'd like to point out is that inside the parentheses, we have a shift. This has shifted it 2 units to the left. So we now can see that the vertical asymptote is going to be where x is equal to negative 2. That will also change the domain. The domain will be from the asymptote to positive infinity, so where x is greater than negative 2. The range, it will continue to be all real numbers. And if we trace it from left to right, it is increasing, so I'm just going to copy this domain, and it is not decreasing. In this next example, I'd like to point out that it has a coefficient of 3, and that has caused a dilation. So rather than the graph increasing, notice that when x is 7, the y is barely at 1. And if we take a look here, we cross when y is 1 and when x is 2. So it's increasing much, much faster because of that coefficient of 3. The asymptote continues to be on the y-axis, so at x equals 0. The domain remains the same, so where x is greater than 0. The range is all real numbers. If we trace it from left to right, it is increasing, so I'm just going to copy this domain, and it is not decreasing. In example 4, let's look at how the function changed. It has a negative in the front, which has caused it to reflect over the x-axis. As we look at these key characteristics, the asymptote has not changed. It is still that y-axis where x is equal to 0. The domain is still from the asymptote to positive infinity, so where x is greater than 0. The range is all real numbers. And if we trace this from left to right, it is now going down. It is decreasing. So I'm going to take this domain and copy it for the decreasing interval, and it is not increasing. And in example 5, if we examine the function, you'll notice that it has a negative sign with the x inside the parentheses, and therefore it has reflected over the y-axis. Identifying these key characteristics, the asymptote has not changed. It is still the y-axis at x equals 0. The domain has changed. It's from negative infinity to the asymptote, so it is where x is less than 0. The range is still all real numbers. And if I trace it from left to right, I'm going down, so I'm decreasing. It's not increasing, and copy that domain for decreasing. These notes you will also find in the red notebook. They just discuss the different types of transformations that can happen with a log function. And on slide 19, these are true or false. So all logarithmic functions have a domain of real numbers. Well, that's not true. This would be true if it was the range of all real numbers. All log functions are going to have an x-intercept. That is true, because if the range is all real numbers, at some point you have to cross that x-axis. In the last one is the asymptote x equals 3. Well, the asymptote for a log function is x equals h, and h is in the parentheses. There are no parentheses here, so the asymptote should be x equals 0. This is a matching activity, so you can go ahead and match those. These are notes that can be found in the red notebook. In slide 22, we want to go ahead and just complete these sentences based on the information above. So the first thing we have to see, is it an exponential or log function? Well, we can look right here. It says log. It's a log function. We also know it's a log function because it has a vertical asymptote. So the function is a logarithmic function with a vertical asymptote at, and this is where x is -2. It is also the h value, so x is -2. The range, it's always going to be all real numbers, or from negative infinity to infinity. If we trace this from left to right, it is decreasing, and its domain is from the asymptote to the right, so from -2 to positive infinity. End behavior. So as we look at the left side of this graph, the x's are going to -2. And as I trace that to the left, I'm going up, so y is going to positive infinity. If we look at the end behavior on the right, x is going to positive infinity. And as I trace it to the right, the y's are going down, so y is going to negative infinity.